Okay, so we go for topic 6, Form 4, Chapter 3, period 3 and transition element. So we have this period 3 la, is 2.8.1, 2.8.2, 2.8.3, 2.8.4, 2.8.5, 0.6, 0.7, 0.8. So all is solid except the last two, chlorine and argon is gas. So silicons is semi-metal, SS. Then this is a common question. The second one is they always ask you about amphoteric. All this oxide, I said the last one doing the oxide, right? So all this oxide, right? Some is called acid oxide. So acid oxides means it can dissolve in alkaline because acid and alkaline can have reaction. So all this can dissolve in alkaline. Then cannot dissolve in acid. It's like acid, no reaction. Then for basic oxide, base is alkaline. Okay, base is alkaline. Alkaline means they can react with acid but can react with alkaline. Same species cannot react. Then for amphoteric is very special. Aluminium amphoteric, so is to both also can react, both also can dissolve. So they will ask about the physical property. So for period 3, normally ask only for two. First is about the physical size. So when going across a period, the radius becomes smaller. The reason is that when you're going across a period, the proton number increase and cause the positive charge to increase. Means, let's say if I give you the idea, it's like we talk about sodium, aluminium, and chlorine. So this one got 11 proton at the middle. This one got 13 proton in the middle. This one got 17 proton in the middle. So when you're getting more and more proton outside, they were able to attract the electron closer because more proton means stronger force. So the explanation will be something like this. If you go down here. So as the proton increase, more and more proton, the size will getting smaller. The reason is because the strength of nucleus to attract electron becomes smaller. 11 is weaker force, stronger and stronger. So all the electron will attract closer because outside is all the negative electron. So the positive will attract all the electron closer to the nucleus. That's why the size decreases. Okay, so electronegativity is everything the same when going across the period, proton number increase, positive charge increase. Then the strength to attract electron also increase stronger. So electronegativity ability to attract electron is also stronger. But one more reason it also becomes smaller because of the size. So you remember group 17, the smaller size easier to attract, bigger size harder to attract. So this is the main reason why they are more electronegative when going across the period. Then for transition element, you need to memorize the special property. They have color ion, means they have different color. Those non-transition, their ion to the color, like Cl minus, I minus, Br minus, no color. Na plus, K plus, all these no color. But transition has color. Then for different oxygen number, Fe got 2 plus 3 plus, nickel got 2 plus 3 plus. So all these have different charge. Form complex ion, like they see hexacyanoferrate 2, hexacyanoferrate 3, these all the complex ion. And it can act as a catalyst in industrial process that, like Haber process use iron as catalyst to produce ammonia. Contact process use vanadium oxide to produce sulfuric acid. Oswald process use platinum to produce nitric acid. Hydrogenation use nickel to produce margarine. So how the question looks like, this is how it looks like. So here you can see 11. 11 we know is this is 2.1, 2.2. So all this period 3. Okay, they achieve shell occupied electron. So when going across the period, what happened? So as the proton increase, so this is 11 proton, this is 14 proton, this is 17 proton. The size will getting smaller because the stronger the force, the more proton at the middle, the stronger the force. When going across the period, atomic size decrease. So because proton number increase cause the positive charge increase, you can see the positive charge getting more. So the strength of nucleus to attract electron becomes stronger. They're able to attract all the electron closer to them. So all the electron will pull closer to the nucleus, that's why the size decreases. So who is semi-metal? Silicon. Then who is more electronegative? Let's say we compare sodium and magnesium. So magnesium is 12. Okay, this is 17. So attraction force, of course, 17 is stronger. So it's smaller size. So if I have one electron here, who will be easier to attract first? This. It has more proton. Okay, it has more proton, so the positive charge is higher. Okay, second reason, this one also smaller size, easy to attract. This one is bigger size, harder to attract. So smaller size also help to attract. So both factor will make it the strength of nucleus to attract electron become stronger. So it become easier to attract electron compared to the magnesium. Okay, then this is another question. You need to know that aluminium is the N4 tertiary oxide. So it both can react because sodium hydroxide is alkaline. Nitric acid is acid. So magnesium can react with acid, means it is basic. Then silicon oxide can react alkaline, so it's acidic. So only amphoteric have both acidic and basic property. So we call it amphoteric. Okay, now give one example of transition element. So it form color ion. Example, copper 2 is blue color. You also have different oxidation number, like iron have Fe2 plus, Fe3 plus. Complex ion can give example, iron form hexacyanoferrate 3 ion. And as catalyst, you can write iron used as a catalyst in the Haber process to produce ammonia. Then we try one actual question. So this is the question, similar. So now they want you to compare sodium and chlorine, the size. So sodium got 11 proton, chlorine got 17 proton. Of course, chlorine is stronger force. This is weaker force, so the size bigger. Okay, so sodium is bigger. So I need to explain reason why not. So because it has more proton in the middle. So to attract electron is stronger. So all the electron will be pulled closer to the nucleus. So this is smaller. Okay. Then for this one, this is alkaline. This is acid. So this one both can react. So it's amphoteric lah. Okay, amphoteric. Then this one can react with alkaline. So it's acidic. Cannot react this. This one can react acid. So it's basic. Then from 2 to 13 is transition element. So this is the 4 property that you need to memorize, similar to example just now. So you need to write all these answers just in case exam they ask you to write.